today we are going to create a project and see how communication between two I2C master and slave happens. Correct?
Yes.
I'll just open my cube ID and here select file, new STM32 project. I think you guys have learn about this how to generate STM32 cube ID and generate project in it, because I have teach this multiple times. Here we will go and select our controller. That is STM. There is an update in STM32 cube ID, so I would ask you all to update your ID. STM32 WB 55 RG, correct?
Yes.
That's our controller which we are working on. We'll just select it and go to this next section. Give our project name, so I will give it I2C. Then finish it. Fine. It will take some time to generate our IOC file. You can see it's generated here. Then we will have to go to this connectivity part and select I2C. You can see there is two I2C in this controller. Everyone can see it?
Yes.
I2C1, I2C3. So what we will do, we will make first I2C as master and second I2C as slave. And we will send data from master to slave on the same controller only. We don't need two different controllers for this testing. We can do this on the same controller because we have two I2C on our controller. So what we will do, first select I2C1. Here go to the mode and select I2C. Just go, you can see here custom timing is disabled. I2C speed, which I have taught you, it's a standard, fast, super fast. So standard, fast and fast mode plus. I'll just keep it at default standard mode because I don't need very fast thing here. Then you can see frequency, raise time, fall time and all. Slave features, no, this is not slave, so I'll keep it as it is. Fine. Slave features I will not select here. I'll keep it as it is. Now I'll go to this NVIC setting and enable its interrupt. Both interrupt. First interrupt will be for event and second interrupt if my I2C gets any error. For that purpose I'll use it. And you can see as soon as I have enabled my I2C1 here, these two pins got selected. You can see PB5 and PB8 and PB9. So I want you all to write down in your notebook PB8 is my I2C1 clock. You can see it, it's I2C1 SCL. Fine.
Yes.
Yeah. So write this down. PV8 is I2C1 SCL and PV9 is I2C1 SDA. So my clock pin is PV8 and data pin is PV9. Tell me once you have written it.
Sorry.
Once you have written this in your notebook or any page, then
Yeah, yes, written.
Yes, yes.
So we have configured our I2C1. We have not enabled slave, so it's in master mode. Then I'll select I2C3 here. Same thing, just enable the I2C here. Now enable its interrupt. What we will do in its parameter, I2C3 I will make this slave, because my I2C will work only when one is master and one is slave. Correct?
Yes.
Yes.
So I have selected I2C1 as master. So what I will select to I2C2, I2C3 that I have here,
Slave.
slave. Fine. Now go to its parameter setting. Its speed should, make sure one thing. If your master has speed mode standard, then slave should also have same speed. If you will configure like your master is having fast speed mode and your slave has standard mode or ultra fast mode, then the communication will not happen. So what you will have to do, select your master and slave as it is. The speed should be same.
Okay.
Okay. Then its frequency and all, I'll keep it default because at my master it's at default. Now I'll have to enable my slave features because I'll have to configure this as slave, correct? So everything is configured here. What I'll do, I'll give this a slave address. You can see primary slave address must be between 0 and 128. Can you see this?
Yes.
Yes.
Okay. What I'll do, I'll just give this slave address. That will be disabled. Here, I'll give this 12. Fine. You can give any slave address. Just make sure your master should have also the same slave address. Your master should transmit at the same slave address. Okay?
Okay.
Okay, so till now we have configured our I2C1 and I2C3. Once again, I2C3 clock pin is set at PC0 and data pin is at PC1. So note it down.
Yes, sir. Noted.
Noted?
Yes.
Now we are good to go. We'll generate our configuration code and generate our main.c. So you can see our main.c is already generated here. Can you see it? Can you see it?
Yes.
Yes.
And you
Yes,
in
sir.
this private variable here we have already got I2C1 and I2C3. That means our configuration of I2C1 and I2C3 is done successfully. Here we have already defined functions which we are going to use. Now we'll have to transmit and receive data. Just like UART, what we will do, we will make two buffers. One will be transmit buffer and one will be receive buffer. Fine.
Okay.
Yes.
What I'll do here, I'll take a buffer of 8 bit. So unit 8 key, and this will be our TX data. So I'll make this TX data buffer. Fine.
Okay.
Now in this buffer we will have to send some data which we want to transmit. I'll say I2C interrupt. We are using I2C in interrupt mode, so I'll just keep my data like this. You can write anything which you want to transmit. Then I'll make one more uint 80 buffer that will be for receiving this data. Rx data. Can anyone tell me why I'm taking both transmit and receiving data in the same code here?
Because of one clock pulse.
So what? All masters and slaves should have same clock pulse and all. But either we can make our device as transmitter, or either we can make our device as receiver. But I am writing code for both transmission and receiving here. So can anyone tell me why I am doing so? I have already explained it in today's class.
Like we took master and slave in both in the same device.
Because in the same device we have two I2C. And I have configured one I2C as master and one I2C as slave. So if I will take same code, it will be burned in the same controller, and my I2C 1 will work as master and 3 will work as slave in the same board. That's why we are doing it.
Yes.
Okay. Now, can anyone tell me what we will do? Because till now we have already communicated with UART in all modes and PWM. So now I want you all to give me some hints what I should do now.
First, we need to declare the slave address.
First, we will have to transmit or
Transmit. Yeah.
Okay, so we have already created this buffer. So next step will be to transmit and receive. Fine.
Yes.
So transmission will be done in continuous mode.
Yes. In while.
So we will use while one, because my master will transmit continuously, and once the slave will receive it, the transmission will stop. If I want, so if my master wants, so if my master does not want it, then he will start. He will keep sending. So here we will use HAL similarly as you are HAL I2C, and we are transmitting as a master. So master and transmit. You can see this function here. Just click it. Which I2C is configured as master here?
I2C 1.
One.
One.
Okay. And what is my slave address?
0x1.
0x12.
1 2.
So I'll write 0x12. Now, whenever you will do register coding or anything, so if you want your code to read 12, read 8, read 9, then you should just double shift it with 1 byte. Okay.
Okay.
So here I want to transmit at register address, the slave address 12. So what I will do, I will write a slave address and bit shift it by 1. You guys know about bit shifting and all. operators, bitwise operators, and
Yeah.
operators.
Yes.
Everyone know this? So I don't
Yes.
need to explain why we are doing this right shift by 1 bit.
If we left shift, then data will change, right?
Yeah. So whenever you want to read registers, either in its data sheet it will be given. Yeah, so in some data sheets and ICs, you will when you will read its data sheet, it will say that if you want to read its device ID, you will have to left shift or right shift its register by 8 bits. Then you will do like this. You will shift that address with 8. But at normal condition, we'll just shift it by 1. So it depends with I2C and all, IC's data sheet and all. But if it's not mentioned, then we will shift it by only 1 bit. So what I have done is I have shifted it by 1 bit. Correct?
Yes.
Yes.
Okay. Now the data that I want to transmit. So what is the data that I want to transmit here?
TX.
So it's TX data. And size, either you can calculate the size or just use size of operator. I have taught you about size of operator in, I think, previous UART polling class. That whenever you want to send the size of the data, you should just use size of string length etc. They come in basic C coding, so you all must be aware of it. And if you are not aware, just listen. Whenever you want to send the size of any buffer or any variable, just use size of and then inside it write its name. So what I will do, size of TX data. Fine.
Yes.
It's done here. Now I'll give some delay. I'll delay 1 second. Fine. What this will do? This will make my I2C1, that is master, to transmit this TX data at this slave address. Okay. So my master code is completed here. What I'll do now, I will receive as slave. So reception will be done not in continuous mode. It will be done only when interrupt of data come here. So I will use user code begin to here. So just write HAL I2C HAL I2C. Now in which mode we are using this? Slave. So write slave, and what we are doing here? Receiving. Receive. You can see this function. Which I2C is configured as slave?
3. I2C.
So I2C 3. Now what we want, in which buffer we want to store it?
RX buffer.
Yes.
And size will be like that, size of RX and data. Fine.
Yes.
Anyone have any doubt till now?
No.
So till now we have done it. My transmission function is ready. My receiving function is ready. Correct?
Yes.
Why we wrote
Yes, sir.
that line above the while loop?
Sorry.
We wrote that line like slave all I2C slave receive that mentioned above the while loop, right?
Yes.
So what is the reason of mentioning that?
Yeah, I've just explained it. Transmission will be done in continuous mode. Okay.
Okay.
So we will have to use, if we want to do something in continuous mode, we will use it in while one. from the first, I think second or third class, I have first class only.
Yeah, I'm aware of that.
Okay. Now coming to the slave part. So in interrupt mode, when we were talking about the UART interrupt, I told you that the CPU will not work continuously. It will work only when interrupt will be generated. Correct?
Yeah.
So what will happen? I the slave receive part, it will only work when some interrupt will come, like that master has transmitted its data, so it will reach to the slave address and it will generate some interrupt that master, I have sorry, slave, I have came at your door, please open and accept me, something like that.
Yeah.
Yeah, so it will work only when interrupt will be generated. So it's not working in continuous mode, it's working only when interrupt is generated. For that reason I'm not using it in while one loop. If I'll use it in while one loop, then what will happen, even when my master is not transmitting this data, my code will go continuously in this slave receive mode, and it will waste my some seconds of time. So if I'm using it for some bigger projects where I'll have to save time, every time it will take my some milliseconds,
Yes.
and that will be worse for that condition if I want to complete some task in like say 13 seconds, 15 seconds for power consumption and all. So for that purpose, we will use it in we will not use it in while one loop, because we want to receive it only when interrupt is received. In the UART interrupt mode also, the receiving part was done outside while one loop. Can you remember it?
Yeah.
Yes.
Okay. So now tell me, is my code ready now? Or we are missing something?
Like we need to include any receive callback function, like you want.
So whenever we use receive in interrupt mode, like in UART also, when we used receive in interrupt mode, what we did, we made a function that was of callback function. So here also, if we are receiving and using it as slave, we will have to make one function that will be callback function for slave. And where we will do this? Here, at this line, user code begin code. So similarly, like UART, I will make this function void, then all I2C. Then what we will do? There we were using UART RX complete callback. Here we will use I2C slave, so slave
Receive.
RX complete callback. Please repeat after me. What we will do, we will make a function void all I2C slave receive complete callback. And here we will add something like that, I2C handle type def. Okay, and make this pointer. So whatever I2C we want to use here, we can use. Fine. Now you may ask that how we know what slave function or slave callback function we have to make here. These functions are already defined. In UART, what we were doing, we were opening our STM32 HAL UART.c. For I2C, we will open our STM32 HAL I2C.c. And here you can see this function is already defined as weak function. So just copy this. If you don't want to remember that line of code, just copy this and paste here. Fine.
Fine.
Okay. Now inside this, we will use. So in UART callback, inside that callback, I was using HAL UART receive interrupt. So for I2C, what we will use? We will use HAL I2C
Slave
slave
receive interrupt.
receive interrupt. Fine. This function. Similarly, we'll make this I2C3. This is Rx data, and this is
Size
size of
Understood.
Rx data. Done.
Yes.
So now our code is complete, or we need to add something else now?
To display Rx data.
No, that will be that we can see in this all I2C slave here. Just put a breakpoint here,
Okay.
and when you will move your cursor at this Rx data, you will see the data that you will receive.
Okay.
So now I'll check whether my code is successful or not. Like if there is any error or warning in my code. You can see my code is built with 0 errors and 0 warning. Fine?
Okay. Fine.
Okay. Now I want everyone to answer. In which mode we have used this I2C? Standard mode, fast mode, or ultra fast mode?
Standard mode.
Standard.
Standard mode. Standard mode, correct? Till now what we have done, we have configured our I2C. We on our controller we have two I2C, so we don't need two controllers. If your controller have only one I2C, then you will have to take two controller, make controller 1 as master and controller 2 as slave. But since this controller have two I2C on the same board, we have configured I2C 1 as master and I2C 3 as slave. Now what we did, we made two buffer. One is Rx buffer and second is Tx buffer. Tx buffer will include the data that we want to transmit, and Rx buffer will receive that data. Fine?
Yes.
Then inside while one loop, because we want to transmit continuously, we write our transmit function, that was HAL I2C transmit, and we sent our data there. Slave address, we shifted it by 1 bit. Why we shifted it? Because in register coding you have to shift it so that the original data can be read. If your datasheet mentions specifically that you have to bit shift it with 8 bytes, 9 bytes, 10 bits, etc., then you will have to write your code like that only. But since here we are using only the controllers, the AVK mode, we have shifted it by 1 bit. Then we have for receiving this data, we have write one line of code outside while one loop, all I2C receive function. Correct?
Yes.
After that, what we did, we made a callback, because whenever you will use in interrupt mode, you have to make some callback for this. So we made callback, all I2C slave callback, receive complete callback, and there also we completed our code, that is all I2C slave receive. So what will happen? The first I2C will transmit some data, and the second I2C will check if the slave address is correct, clock is correct, and everything is correct. Then the second I2C will receive that particular data. Fine.
Yes.
Now what we have to do?
Yeah.
We cannot. What we have to do? We have to debug this code and burn our code in the controller. But before that, since I have one controller and its master and slave, and in the theory part, I have told you that for transmission, clock pin will be connected to the clock pin of slave, and transmission data pin of master will be connected to the data pin of slave. So both pins should be connected and its ground should also be connected. Whenever you connect two devices, first connect its ground because the power supply will be same there.
Yes.
Okay, but since both these I2C are available on the same board, we don't need to connect its ground because its ground is already same. So what we need to do now, we have to connect clock pin of I2C1 with clock pin of I2C3, data pin of I2C1 with data pin of I2C3. Fine. And what we will do to know where these pins are selected or where these pins are available. Not at the pinout, we will see schematic.
Love our content? Hit subscribe for more awesome videos. We'll see you in the next one.